Welcome to episode 5 in the Merlin 128 series. I thought I would close out the series with this video by writing a short program using inspiration from the Commodore 128 assembly language programming book by Mark Andrews. This book here, I'll post the download link in the video's description. What I like about this book is that it has example source code written in 3 different assembler programs, and Merlin 128 is one of those programs. The program that I wanted to kind of work off of, I'm not going to copy this verbatim. Certain parts I will, but what I wanted to do was sort of take this as inspiration and then write our own variation of it in the Merlin 128 assembler. One thing I was looking for, which I could not find, was the program listings from this book. I was kind of looking for that. If anyone knows where those program listings are, that would be really cool to find those, so we don't have to type them in all over again, such as I'll be doing on this video, a little bit of that. Anyway, in Merlin 128, I'm going to go into the editor, and we're going to make sure we're in a new program, and we're going to do E for edit. The parts of the program that I thought I would copy are the first few lines of the program where you do the org 1300. Go ahead and use some of these equates. I thought I would do the EOF, which equates to 03. The EOL equates to 0D, which is basically like a carriage return character. We'll do the BSOUT equates to FFD2. So if you call that, if you JSR to FFD2, it will print the character that's in the accumulator. We'll do the basic in, and what this does, well, it equates to FFCF, and if you JSR to that routine, it grabs a character from the input buffer using the basic ROM. We'll get the buffer length. So we need a buffer in this program to input some text, and we're just going to do 40 characters. We need a temporary pointer, which the program uses in 0 page, points to FB in the 0 page. And then to start out the program, I thought I would do, we'll do a label for the top of the program. We're going to write a routine, but we're going to first JSR to it, basically like a hello world or to get a greeting. And I wanted to call it greet. And we'll add to it. What we're going to do is go ahead and jump to top for now. So it'll just loop forever until we run, stop, and restore. So at the bottom of the program, what I thought I would do is go ahead and code up a message of some kind. And I was going to call it a welcome message. The very first thing I wanted to put in front of it was the hex string 0D, which brings it down a character, brings it down a line. And then the text. I want to try to make a guessing game. I'm thinking you guess the name. So the first thing it's going to say is, welcome, guess the name, question mark. And then I'm going to put a space at the end so that when you're entering with the input command, it's not right against the question mark. And then I would put a 00 at the end to 0 terminate it. Okay, so then what we would do is write the greet routine. So we'll have greet, we'll load less than, we'll load the lower byte of welcome and store it in that 0 page pointer. And then we'll load the high byte of welcome and store it in the 0 page plus 1. If I can find the plus key. There we go. And we're going to need a routine that actually will print the text, and we're going to go ahead and mimic the one that's in the book, and it's called print. Let's see if I can find it. Right there. Okay. So we're going to JSR to print, and we're going to return back. Now, you'll notice when you do a JSR, And then on RTS, you can save a byte by saying JMP print, but we're not going to do that now. Let's go ahead and use the program that is written basically in the book. So we'll go print LDY 0, so we're going to create a loop, show LDA temp pointer. Notice we're doing the address mode, comma Y. So that means we're going to load the address that's at FB and FC, comma the Y register, which is in this case would be the welcome command. We're going to compare it to the EOF character. Instead of EOF, we're just going to compare it to 0. And if we're equal to 0, we're going to go down to done, which would basically be like to return back. And then we're going to push the value in the accumulator, JSR to BSOUT, which would output the character, pull the accumulator back, pull in the accumulator, compare it to 0, branch if not equal to next, jump done, and then next is going to say I and Y, compare Y to the buffer length, branch if less than to show, and then that's basically the entire program. Now the way we have it written right now, when we run it, it will print this over and over until we kill it. Let's just see if we got any typos. We're assembling it, looks good. We're going to go back to the menu and then we're going to save it. Our object code, and we're going to run it. Okay, so there it goes. So I think how we can break this is by doing run, stop, and restore. If we hit escape on the keyboard and then page up, it does basically a run, stop, restore. Then we can go back into the editor and we can continue where we left off. Alright, so now that we're back in our program, let's go ahead and write the routine that will input a line. So let's jump subroutine to input a name, and we'll add it right here, get name. For this, it's very similar to what's in the book. Let's kind of go down. Let's look for it to this right here, input a typed line. I'm not going to do the fill, the JSR fill, but we'll do the rest of it. So we'll do LDX 0, JSR to grab a character, basic input. And on that line, instead of key, I'm going to call it loop. Then we're going to store it in the text buffer, comma X. So we have that little text buffer, or we need to create one. So we don't have it yet. The way the book shows us to do that is right here. You have a text buff DS40. I prefer to put it down at the bottom rather than where they're putting it. So we're going to do text buff DS40. And looking at what DS does, let's look that up. In the Merlin 128 manual, DS is defined as defined storage, and if you put a DS followed by a number, it will zero out that number of bytes in memory. So it's basically a quick way of zeroing out. Except with this one, we're going to do buffer length on it instead of 40. That way we could change it later on more easily. So continuing on with our program, so we're going to store it in our text buffer, comma X, compare it to EOL, which is the in the line character, and then BEQ to compare. So there's another routine we'll have to write, which is right below it, right there on the screen. Increment the X, and then jump back up to loop instead of there. And then down here, compare. Let's flesh out compare in a minute. But for now, let's just see if this thing works. We got the JSR for greeting and JSR get name. And then once we've entered the name, then we can then move on to what compare is supposed to do. So let's assemble it. And run it. Okay, so now you see it's not looping infinitely. Well, it still is, but not printing infinitely. And so all we're doing is we're entering characters and nothing much else going on, but at least we're making progress. So now let's flesh out this compare routine. I'm getting rid of the bsout compare. I'm just going to do an LDX 0. And we're going to have to create a label. LDA text buffer, comma X. Compare it to the name, comma X. So now we need a label to some variable that we're comparing this against. And the reason why I named this thing George is because I thought our comparison could be George. Because they use the name George in here. We have name and then ASC George right here. So I thought I would do that here, and we do ASC double quotes George, and then uppercase version of it too. And then we terminate it with the 0D, which is a line feed. So we're going to compare everything to that word George. So that's the correct thing to enter is George. So we're doing our comparison. Branch if not equal to, we're going to go to a label. So basically print out that's the wrong answer. Compare it to the EOL character, which is the 0D. Branch if equal to, we're going to need a routine, a small routine that prints the word yes, you have guessed the correct name. Otherwise, increment the X register, compare the X to the buffer length, branch if it's greater than or equal to yes. Otherwise, we're going to jump back up to check and loop the program. So we have a few things we have to flesh out with this wrong one and then the yes. So down here at the bottom, let's create some more labels. So we can go with, I think, correct. And I'm going to put some carriage returns in first. And then I'm going to do basically correct. Welcome, George. So if you entered the right thing, it's going to print that. And then at the end, I'm going to go ahead and put a 0D and a 00 to terminate the string. So that's if you're correct. But if you're wrong, if you entered a bad name, then I'm going to do the same thing here. I'm going to do a 0D, 0D, but then also print the text, incorrect, name, entered. And I'm going to put a hex 0D00. Basically just puts a line space above and below the text that you're printing out. So just got to remember it's correct and bad name are the labels. So we'll kind of do that right there. So wrong, we could put the code for wrong right here and the code for yes right here. So what I thought for wrong, what we'll do is we'll load bad name, high byte, low byte actually. I need to do that low byte. Store it, temp, ptr. The high byte, store it at temp, ptr, +1. JSR print, just like we did in the other message, and then return back. Yes is going to be the same exact code, so what I'm going to do is going to go Control C, down arrow, Control C again, and then see if I can't paste it in, Control P, and then instead of bad name, we're going to do correct. correct. So this will print you entered the bad name here, and this will print you entered the correct name. Oops, I got two RTSs. Control D to delete a line. There we go. And I don't know, let's see if this will even assemble. And I like to save when I'm done, or when I made some changes. Incorrect name entered. Let's see if it gets our name. Notice if I enter lowercase, it's definitely not working. Uppercase does work. So basically we have an endless loop right here, and we have no way of getting out of it. The next thing I wanted to fix is to break out of the program without having to hit run, stop, restore. So let's go into the editor. So what I thought, somehow I need to break out of this loop right here that's running, this jump to top after it gets the name. So what I thought I would do is have the get name return back a value of 0 or 1, or a register flag to check that. What I was going to do is say branch if equal to 0 to exit the program. And then down here we have exit PRG just to kind of break out of the loop. Now in order to implement that, we'll have to modify this get name routine. In order to make this work, I think instead of branch if equal to compare right here, what I wanted to do is instead jump subroutine to compare. After it gets your name, I think it makes more sense. You put the greeting, then you input the get name, get your name entered, and then you compare to see if the name is the same as what you're trying to check on. And then down here, instead of BEQ down to the compare routine, we'll just do like a branch if equal to exit. Kind of change this around a little. Let's see, exit. We'll just do, we're going to have an RTS in there. I figure what we can do is a CPX number 0. If X is 0, that means you didn't enter anything, and then it would return back. My idea is just to compare X to 0. So we put in, if we type in something, it does that, incorrect name. But if you just hit enter, back to the menus, right? That's better, I think, than doing run, stop, and restore. But one of the things I had noticed here when you're entering the name is this does this jump loop. And so it will go way past the buffer length if you don't put a check for it, which could cause problems later on. So I think to fix that, what I would do here is compare X to the buffer length, and then instead of just jumping up there, just do a BCC to loop. Branch if the carry's clear. If it's less than the buffer length, then jump up to the loop. And then also, I figure we load a X here to 0, so you would break out of the loop. And so that will prevent the program from crashing. Let's go ahead and run it. So if you're entering just a little, but if you go greater than the buffer length, I don't know how many, I think it's 40, right? And you hit enter, exit the program. That's what that does. The next thing I wanted to do was, right now you're forced for this to run and say correct. You have to enter it all in uppercase. And I wanted to fix that. So let's go back into the code. My idea to fix that is to, during the get name routine, if we were to, right after you input a character, if you were to compare it to the letter A in the ASCII chart is 41. And what we want to do is make sure it's between A and Z. If it's between A and Z, then we can assume that it is in the lowercase range and we can make it uppercase. And so what I was going to do is branch if less than that when we don't care, and then compare it to, and I had already done the research, looked it up. 5b is the letter right after z. And so we want to say if it's greater than or equal to that, we want to skip, kind of like a skip, kind of. So we'll create a skip here. Now if it's within the range, so it's in between, oh, we did do it here too. If it's in the range of 41 to 58, then what we'll do is we're going to clear the carry and then add 80 to it, and that will make it basically whatever character you enter, instead of being in lowercase, it'll be in uppercase. So when you hit save, yeah, it'll save it all uppercase, but then when we do our comparisons, we don't have to change the compare routine. There's a couple of ways of going around trying to fix this, but that was my idea. Let's see if that assembles. It's always a question mark, is it going to assemble or not? So we put in garbage, we get incorrect name. If we enter George in uppercase, it says it's correct, garbage. Now we do George lowercase, it says correct. If you mix the case, you go G-E-O-R-G-E, it will also be correct. So now, the final thing I wanted to cover on this video, and this video is extending longer than I wanted it to, would be to go ahead and add a macro. So because we have this little bit of code right here, it would be very easy to make that a macro. What I'm going to do is go ahead and copy this, Control-C, down arrow, Control-C again. The macros on Merlin 128 need to be above where they're being referenced. So I'm going to just put it up kind of here near the top by the equates. And then I'm going to do Control-P to paste that in. If you do Alt-M, that gives you your macro code here. We need that line moved, so I'm going to do Control-C, Control-X, and then paste it at the bottom, Control-P. Control-D, we don't need an RTS in your macro. Now instead of saying correct here, we're going to change that to the first parameter. In order to do a parameter in Merlin 128, it's that right bracket. So the first parameter 1 is the first parameter you're passing down to the macro. And then instead of correct there, greater than correct, we're going to do parameter 2. And we're going to leave the JSR in there. And then we got to give the macro a name. I thought I would call it PR text or print text. And then wherever we do a printout, as long as we pass the parameter down to it, then it should substitute that code in automatically for you when the program assembles. Let's kind of go down and put the macro in place here. I'm going to do a Control-D to snug that up. For example, right here, we would just go PRTXT bad name, and then we would get rid of this. And then here it's the same thing. It would be PRTXT correct. So we're going to print the text correct. And then we'll get rid of this. And then there's the greeting. We could change that one out as well. PR text welcome. And then we eliminate these lines. And I think that's it in the program. What I want, I know you can hit Control up arrow to page up and Control down arrow to page down. But I want to enter the Merlin 128 comments. And remember, if we're recalling from the previous video, Commodore asterisk gives us a line like that of asterisks. We can do 2 of those. And then in the middle, Commodore up arrow gives you your asterisk with 30 spaces, and we can basically go. And if you wanted to, we could actually Alt and then the British pound to give Merlin 128 the credit. And let's just see if that assembles. Or, oh, I got a bad character. So I messed something up. Let's go back in. I must have messed something up in my macro. Just looking at it like, okay, we have our macro here, but we're only using, it took me a minute to figure this out. We're only using 1 parameter, not 2, so it's less than the low byte, store it in the temp pointer. The high byte of variable passed down, store it in the temp pointer plus 1. That's the ticket. Let's make sure the program runs. Correct. Correct. And then when we're done, I just hit enter. Anyhow, that is my video. I could go on and on and on different concepts and everything, but I thought I would end it here. Hope you enjoyed the video. Thank you for watching.